All right, example 21. At the start of Christmas break, yay, Christmas break. That's coming. That's coming again real soon, in about 11 months. At the start of Christmas break, at t equals 0 days, a man weighed 180 pounds. If the man gained weight during the break, right? Pretty naturally, right? And I'm not mentioning any names or even saying that it's me. Okay, I have a weakness for fruitcake. Yeah, a weakness for fruitcake. My aunt makes a terrific fruitcake, and I'm vulnerable to it. And I'm also vulnerable to wonderful chocolate-covered pecans. Yeah, from Garrett's family. Pecans. Yeah. And so, yeah. So I mean, this could be me, but maybe not. But if he gains weight, this unknown individual, this male, if he gains weight at a rate that's modeled by this function, okay, so now if the man knows the function that models how fast he gains weight, he must be some kind of math dude. Pounds per day. Oh goodness, pounds per day. Hitting the chocolate-covered pecans pretty hard. What was the man's weight in pounds at the end of the break 14 days later? Show your integral setup and don't judge. Okay, all right. So this is a nice accumulation problem, right? The weight of the man at any given time is really a function of two things then, right? The weight at which he started, which was what? 180, plus the weight that he accumulated since that time over the 14-day period. So here's what we could say. W prime is the rate of change for the weight. So we could say that his weight at day 14 is W of 14. Okay? The weight at day 14 is his starting weight. What was it? 180 plus the net accumulation. That would be the integral from the starting time when he was 180, which is t equals what? 0. To the time we're getting to, which of course, if it's W of 14, that should be 14. So when you set this up, remember, this number here should match with that number, and the independent variable for 180 should match up with that t or x value, whatever it is down there. Those should match up. Of the rate equation, W prime of t, that's the rate equation for W with respect to t. So there you go. That would get 2 checks right there. One for the integral, and then one for adding the 180. And now that we have it, all we have to do is go to the calculator. So I'm only going to do this one time, so I'm not going to take the effort to type this into Y1. I'm just going to do it straight from my home screen. So 180 plus, and of course the quick version, the quick way to get to the integral is Math 9 is a little bit faster, one fewer keystrokes than alpha F2 4. Which also gets there, alpha F2 4. And of course, you don't want to take a double integral because that makes it very, very challenging. Well, you would have to evaluate the integral as the, yeah. Okay, so let me start over. 180 plus Math 9 is the quick way to do it. You'll get used to that. Math number 9. Yeah, still on the top 10 list, though. All right. So 14 of, and now I can't recall Y1 because I didn't type it in there, so I typed in 10 sine of pi t8. So again, we'll just use x instead of t, divide by 8, and then of course back here we put x. So again, you could use any variable you want. You could use alpha a there as long as you put d alpha a, but x is a shortcut. Now, before I hit enter, wait, I better come back here. I think I need to close this again just to be sure. Okay. Before I hit enter, I hit the sign button. I better make sure I'm in what mode? Radian mode. I was in degree mode earlier today because I was calculating some angles in degrees, but I am back in radian, so I'm checking. All right, so I'm good. Come back to here, and we'll hit enter. And there you go. So his weight 14 days later was 187 pounds. So W of 14 is 187.458 pounds. I'm just going to write the word pounds instead of doing the obvious abbreviation for pounds, which is LBS. Yeah. Okay. So there you go. So does that mean that the guy only gained 7 pounds over the entire 14 days? No. Remember, that means his net accumulation was 7.458. He could have gained, 15 pounds in the first week and then come back and lost almost 8 pounds. But at the end, he netted a gain of 187 pounds. Now, it might be interesting to graph the function and see how his weight fluctuated, right? So while I'm doing that, someone use your iPad and Google, why is LBS the abbreviation for pounds? So we can, okay, get my phone going. Let's see if we can do that, all right? Okay, Google. Come on, Galaxy Note 5, it's supposed to work. Okay, Google. No, what's wrong with you, Google? Okay, Google. Why do we abbreviate pounds to LBS?
According to Mental Floss, pound is an abbreviation of the Latin word libra.
The primary meaning of libra was balance scales.
Balance, scales, pounds, libra. Nice. Thank you, Google. Okay, Google. Thank you.
You're welcome.
All right, so, hey, Google. Okay, Google. Okay, Google. I think you're better than Siri. She's being modest. She got shy. Oh, yours did? Yeah, she got nervous. She's like, "Oh, I don't want to be on YouTube." All right, let's go ahead and graph this in a nice window from 0 to 14. And then let's think of what an appropriate Y scale is. Just to kind of review trig functions, there's no plus D, so this is just the rate equation. I guess we have to find the antiderivative. Oh, the rate of change of weight equation. So let's see. What is the amplitude? 10. So we should be able to go like down, up. Let's see, down to negative 12 maybe, up to positive 12. And let's go ahead and graph it and see what it looks like. So remember, this is not his weight. This is the rate at which he's gaining weight. So notice when this graph is positive, he is what? Gaining weight. And where this graph is negative, he is losing weight. So he wasn't gaining weight consistently up to 7 pounds. He actually, towards the end there, lost. Now, if we want to figure out essentially when was he his heaviest during this time, what could we do? At what time was he his heaviest? Yeah, basically the first derivative test. If this is the derivative, we want to know where this graph crosses from positive to negative. Because when W prime crosses from positive to negative, we have a local max. But because we're on this closed interval, this local max will also be the absolute max. So can we figure out where that is? Yes. And here's the quick way to do it. If you graph 0 down here, let's graph it. You can find the X-intercept. We could also find it algebraically using the unit circle, but let's just do it this way. Second trace, number 5. Enter, enter, enter. Come on in. Are you bringing chocolate-covered pecans? Come on in. Enter, enter, enter. It intersects at 8. So here's what we could do now. If we want to figure out when he was his heaviest, we can go back to the home screen, and let's set it up here first. Let's go ahead and say the man is the heaviest when m prime of t equals 0, and this is at t equals 8, it's the absolute max. So we could figure out the man's weight. So W of 8 is going to equal what? 180 plus the integral from 0 to 8 of w prime of t. Okay, now this might be an indictment on this guy, but we'll do it. 180 plus math 9 from 0 to 8. And notice we could have found the integral from the graphing screen. It would have shaded it and given us his net gain, and we could have added it to 180. But a lot of times we're dealing with a number like 180 that's not so nice. So it's best just to go back to the home screen, recalculate it. Vars, y vars, function, enter. There's another way to get y1 because I have it in y1 now. And I can just say with respect to x. Whoa! Yeah. Now notice we're gonna truncate here instead of round, just so we're not making the guy any heavier. Okay. 230. He got up to 231 pounds. Those are some great pecans, and let me tell you, they were. Thank you very much. And it was some really good fruitcake as well. Thank you, Aunt Janice. Huh? Yeah. What was the company name again?
Bragg Pecans.
Bragg Pecans. Yeah, that's right. I should have remembered it. Bragg Pecans from Hondo, Texas. Bragg Pecans. Just go online or go to Hondo. Yeah, and just get some Bragg Pecans and then balloon up to 231 pounds. Okay? Yeah, they're good. They're very good. 0.9, right? 230.9. So that's a pretty talented guy, right? To gain 50 pounds in 8 days, and then to end up losing whatever he lost to get back down to 187. Yeah, 43. That's the talent. Okay, that's like David Blaine kind of talent, right? Like put him in a box and watch him balloon up to 50 pounds and watch him shed weight. Okay, anyway, he's done stuff like that. David Blaine, the magician. You don't know who David Blaine is? He's a guy who held his breath for like 22 minutes on the Oprah show. He did like lose weight like really fast. Anyway, kind of a nice question. We are done with this section. I'm just going to say one more thing. Bragg Pecans, Hondo, Texas. Get you some. Or just call Aunt Janice and say, I need some of that fruitcake. All right.